All right. Thank you, guys. Thank you for coming. Today is Friday. So, what we do on Friday, we do a lot of slide presentations on SQL, and then we'll basically get started with the data enthusiasts that you are. So, today we're going to be talking about relational data model. And as the name implies, when we talk about relational data model, it's more like the mathematical model for designing databases. Okay, so when we design databases, we basically want to take a look at the attributes and the entities that comes along with it. So when we talk about RDM, which is when you see RDM, it's a relational data model. It basically represents data as a two-dimensional tables, relations. That model, entities, and their relationships. Okay. So let's just take a look at what we need to dive into, and we'll walk through it accordingly. All right. So tonight we're going to be covering the introduction. We're going to cover the important terms, restrictions, entity integrity, referential integrity, relationships. We're going to cover the pros and cons, which is more like the advantages and disadvantages. Then we're also going to conclude and do some small classwork just to get us acquainted with the topic as well. So I'm going to go deep, I'm going to go light. So feel free to put your questions in the chat, and Francis will basically point it forward. All right. Thank you so much. Thank you so much, Francis, for your hard work. I appreciate that. So, oh, good. So, just like I mentioned earlier, relational data model is like a abstract mathematical model on the basis of which modern databases are designed. So there are some databases that basically aligns with this model. MySQL, we're currently using MySQL within our classwork and the tables we have created. And we also have Progress SQL, we have Oracle, and a whole lot of them. Okay, so knowing about the relational data model will help you better understand the concept of building modern databases, and then it will also help you ground your knowledge about information systems. Okay, so we're also going to learn about how to design robust information systems, just like how you've designed users underscore your name table. Okay, so trust me, I'm proud of you guys who basically created tables. We have more than 150 users underscore name table in the current U1 databases. That's a good one. But tonight, you're going to understand what each of those errors you've been seeing when you try to add data. All right. So when it comes to a table, the table that you have, there are some important terms that you will never forget. One of the important terms is the most important part is relation. Okay. So a table represents an entity or a relationship. A table represents an entity or a relationship. Okay. And a relation basically is like a two-dimensional table that represents some entity or relationship. So an entity basically is an abstraction of a real world object, just like how we think about our table, right? We created our users underscore your name table, and you can basically feel that table like it's a real world. So that's an abstract, meaning that you have a first name on that table, you have a last name on that table, you have your age, you have your country, you have your sign up date. So like a real world object. So when you take a look at that table, basically the table you created for yourself, the table basically seems to be like an organizer for you. You have the person's email, you already have, the contact of that person, where the person stays, the country where the person resides. It's just similar. You're feeling like a real world. Okay, so an attribute basically is the column you have in that table. An example of that is a column you have in your table: first name, email, age, country, sign up date, user ID. That is an attribute. Okay, so a tuple basically is a row in a table representing a specific record. Say, for example, let me pull up VS Code, and then we'll run a table real quick. So basically, if you take a look at this user ID, this is called an attribute. It's an attribute of the table, like a characteristic of the table. So user ID, first name, we all know this as the columns, right? Last name, they are attributes of a table. So now I've basically queried this table with a limit one. Every content of this one, user ID one, first name Hope, Dion, email, age, USA, and sign up date represents a tuple. We call that a tuple. It means a row. This is a row, like this is a row. Okay, it's a row. This row across a table represents me. If I do two, if I do two, if I do two of this, you say this is me, right? This is me. Now see another person. You can see Bob Smith. You can notice that row two represents Bob. Bob Smith, Bob at customshop.com. That is one row representing one person. That is a tuple. Okay, that is a tuple. So when we talk about an entity, right? The entity is users. Your table is where we talk about the abstraction, the users. This is the entity. Okay, so understand the entity is your table itself. You can say that table basically, this table looks like an address book. Okay, hey, Bob Smith works for Custom Shop. Hi, he's 35 years old. He lives in Canada. He was registered to he was registered to Custom Shop on the 25th of February 2025. Yes. So similarly, you can say Carlos represents another tuple, which is a row. Carlos Lopez. He lives in Mexico, and he's 22, 25 February 2025. So basically, understanding this concept is very, very important. And again, we'll get to see how the relationship ties to this table. Okay. So you will notice that when we say a relation, yeah, you see a table represents an entity or a relationship. There is a relationship between user ID, Bob. You can see user ID 2 is tied to Bob, Smith, and others. Similarly, user ID 1 is tied to Hope. All right. So we'll take a look at this as well. User ID 3, you can see there's a relationship. So if we go to this table and we decide to find whose user ID is 3, you can notice that if we do this, we'll probably be pulling the person with the user ID 3. Okay, so we'll probably be pulling the user ID 3. You'll notice the relationship. User ID 3 is tied to Carlos, Lopez, and all that. Okay, so let's jump back to the presentation again. So in summary, we basically can say a relation is essentially a two-dimensional table, row, and a column that represents some entity or relationship. And we can see our table. And then an entity is an abstraction
Sorry,
of some
coach.
object. Okay, like a
Sorry, coach.
class in an
Can you increase
object-oriented
your
programming.
font?
Yes, I have the receipt. Here's the receipt. I'm gonna purchase this.
All right. So if you're not speaking, please stay muted. Class is being recorded. Thank you. So a relationship basically defines how entities are connected. For example, if we're referring to a student table in one of the groups, we can have a relationship where it's many to one relationship or more on the types of relationship we progress as we progress. So let me go back to that table again and you see what's going on. So if I take a look at this table, this current table, you will notice that a user ID is tied to one user. A user ID is tied to one user. So in a situation whereby a user ID is tied to multiple users, we want to call that one to many. And there are different examples to that. Okay? There are instances where you have a one-to-one relationship. There is one-to-many relationship, and there's also a situation where you have many-to-many relationship. Okay? Let me try to give you an example of a one-to-one relationship. All right. So, for example, if you've been through college, you would understand that only one person is assigned a matriculation number. You do not share matriculation number with any other person. Yes or no? That's outrightly yes.
Yes.
Okay. Okay. So that is a one-to-one relationship. So let me give you an example of a one-to-many relationship. Say, for example, you are registered at a hospital. Okay. You have your hospital number, but in that hospital, there are many doctors, right? So do you have a particular doctor that can basically attend to you? No, you can be attended to by any doctor. That is a one-to-many relationship. If you're basically, okay, let's say, for example, you're assigned to a doctor and your doctor is on leave and you need to be attended to, another doctor would attend to you. You can see by the time you pull your data into a database and they want to see your health records, they would see your ID, your hospital ID, and then they will see the doctors that have attended to you. So ID 1, if your ID is 1, doctor that attended to you, Doctor 1. On the day you came back, ID 1 and Doctor 2 attended to you. So there is a one-to-many relationship. Okay? All right. Let's take a look at where you can have a many-to-many relationship. All right. So now take a look at this. You're in a library. All right. And you want to borrow a book. And your name is tied to that book. Right? You have a library ID, and that book you borrowed also has a library ID. So when you borrow that book, you return that book to the library, Another person with a library ID borrows that book and returns that book to the library. Another day, you feel like, oh, that book is so interesting. You borrow that book again. You can see that the ID of that book is tied to you, to your friends, to your colleagues, to other library users. Does that make sense? Yes. I'm trying to use real life scenarios. You can see how your IDs represents a real life scenario in terms of your tables. Okay. So let's go back to the presentation one more time and see example of relationships. Okay. So we basically have a many to one relationship, and we'll get to learn more about the types of relationships as we progress. Okay. So let's jump to the next slide. Oh, nice. We basically done this by just going through the table, where we basically took a look at the attributes, the student number, say for example, student number, last name, first name, and date of birth. So, but we decided to use the table that you created, which is the user underscore name. And you can see a relationship within those tables, and you can see the attributes as follows. So for the attributes, you remember I mentioned that the attributes are the columns, the column names of that table. Okay. Like for this student table, the column names are student number, last name, first name, and date of birth. And for these values that we have for these values on this particular row, which we call a tuple, represents a record of this table. You can see the unique ID of the student, and you can see as we progress. Okay. All right. So basically, that's what I was showing you on VS Code when we decided to query that table as well. So there are some restrictions. There are some restrictions while creating the table, and I can also tell you when you were creating your user underscore name, when you created the table, and then you decided to do some operations on the table in terms of inserts and all that, you would have experienced those restrictions. You would have experienced those restrictions as errors that you're trying to fix. So the restrictions basically, I'll try to explain them. Your table names will be unique. So if I have a table called users underscore hope, if you try to create another table with users underscore hope, it won't work because no two tables or relations in the same database should have the same name. No two tables in the same database can share the same name. Again, for the column names, which is the attribute names, in a table must have a unique name, meaning that you cannot have a first name and a first name. So you'll notice that all the names in our columns are unique. So you cannot have a user ID again, and a user ID. So it means that you can only have one unique user ID, one unique name across the table, meaning you have user ID, first name, last name, email, age, country, with all due respect, which is very, very important. No duplications across this. All right. So there's another attribute we call atomicity. Each cell in the table must contain a single value. Atomicity. Each cell in the table must contain a single value. And then another thing you need to note is the order of irrelevance. the order of rows and columns is not significant, meaning that first name can come before user ID, last name can come before user ID, email can come before user ID. It doesn't matter. It doesn't matter. The order of rows, the way you order them, doesn't matter. It's just like when we're trying to make a create statement. Try to make a create statement. I can take this. It's just like me saying this last name can be before this. It doesn't matter. Okay, it doesn't matter. And note that this, after creating this table, users hope, I cannot create this table anymore because each table must be unique. Table names must be unique across the database. So if you find time to take a look at the tables we have under here, you will notice that all names on this table are distinct. There is no duplicates. They are all unique names. Okay. All right. So let's go back. So let's just recap this again. There cannot be two relations with the same name in a database, meaning there cannot be two tables like with the same name. When we talk about relations, okay, get it that we're talking about table. Two tables with the same name in a database. All right. All attributes with the same relation should have different names, meaning all columns should have different names. There should be only one value in each cell. Oh, I didn't show you that part as well. You can see that when we query this, you can see we have one value in a cell, one value in a cell, one value in a cell. See, this is a value. This is a value. One value in a cell, one value. All right. One value in a cell. All right. All right. Then the order of rows and columns in the relation is not important. However you order the columns and names, they do not matter. Okay. So let's take a step back. Let's understand some few things. So when you were querying or when you were creating your table, you notice that we decided to make user ID the primary key. When you take a look at your table and when you click on your table name, you see a key behind user ID. It means that we implemented that table using a primary key. All right. All right. Yes. Sorry about that. So integrity in a table, we want to refer to entity integrity and then referential integrity. With integrity, basically, we want to make sure that our model conform to our data rules. Okay. We want to make sure that each row in a table is unique. That is for entity integrity. Okay, just like when you say, hey, this man has integrity, it means that this guy follows certain rules and he has principle. So when they say, hey, we want to make sure that our table has integrity, then we begin to talk about the table integrity itself, which also you want to call entity integrity. You want to ensure that each row in a table is unique. And we basically implemented this table using a primary key. So let's take a look at our users underscore hope table, where the user ID is a primary key. Okay. So guys, basically we use describe. When we use the keyword describe users hope, I'm saying describe this table. Okay. So let's take a look at our table. You see, we have the user ID field, we have the first name, we have the last name, we have the email, we have age, we have country, we have sign up date. And then notice that we have a null, no. But the age can be yes, the country can be yes, null. See key, primary key, PRI, user ID. And then it's auto incremented. So let's look for the user's hope table real quick. I want to demo that using the user's hope table, so we don't go too far. Okay, so you can see the primary key here. It says denoted by this golden key, which shows that this is a primary key. Okay, so with this primary key, it ensures that we have unique row across the table. Okay, so let me run this again. Let me run this again. Say select. You can see that the user ID 1, 2, 3. You can see no row is a duplicate. No row is a duplicate of the other. So the primary key is totally enforced here. 1, Hope. 2, Bob. 3, Carlos. All right. So which is typical of your table as well. There is the referential integrity because we have a primary key, which enforces that no duplicates on your table. So this also reminds you of when you were trying to like do some insert statement and you were trying to insert emails that are same. You kept having duplicate error till you had to like update or edit the email to be different before your data could be ingested. So this is what this key does. It makes sure that you have those rules, those conforming to making sure that's tough. Conforming your tables to a rule that doesn't allow duplicates to be ingested into your table. All right. All right. So cool. Let's jump into the slide again. So it says the integrity of the entity means that there cannot be two identical rows. Two identical rows. Remember when we talked about emails, you editing emails or updating emails due to the fact that you're trying to insert and you're getting duplicates. So as in the real world, we cannot have two absolutely identical objects. For example, there are no identical students. We talked about that earlier, where my matriculation number and your matriculation number cannot be the same. All right. So they are all distinct. They are all distinct. So we need to maintain integrity of an entity with the concept of a primary key. That is what we basically talked about. You see how we used the primary key on user's hope, where user ID 1 is Hope, user ID 2 is Bob, and user ID 3 is Carlos. All right. So let me take a look at that table again so you guys will see what we're talking about. Remember, this is the primary key, and this is enforcing that only 1, 2, and 3. So if you think it's different from any other table, let's pull a table called let me just take a look at a random table. I'll use users Romeo. Let's take a look at users Romeo. Users Romeo. And we can infer what's going on there as well. So if you take a look at users Romeo, you can see that kicking off from 908, all right? And let's take a look if we have 2 of this 908. So you understand the importance of this primary key. With the users Romeo table, it has a primary key as well, and then you can see the importance. So this is the users Romeo table, and we're going to close it, and we're going to look for this 908 table. All right. So we notice that we only have a unique row 908. 908. All right. So this is basically saying that we have a distinct primary key which basically maintains the integrity of an entity. It maintains the integrity of the table. So take a look at this snapshot. You can see student 001, Jane 003, 002, they all have unique IDs. They all have unique IDs. Okay, 01, 02, 03, 05, 04. They all have unique IDs, similar to what's going on right now. Okay. So let's take a look at entity integrity, okay, by graphical representation. So just to recap that, where we talked about entity integrity, we want to, that primary key basically ensures that we have a unique row across our table. Ensures that each row in our table is unique. And we do implement that using a primary key. Okay. The example is the primary key you have on your own users underscore your name table. We implemented that using user underscore ID. Okay. The other part here that we need to talk about is the referential integrity. Okay, so in one of the core definition of this is with referential integrity, it helps maintains consistency between related tables using a concept called primary foreign key. Okay, try to understand what I'm talking about, and I would give you a real life scenario of that as well. Referential integrity, it helps maintain consistency between related tables via foreign key. So let me try to utilize our social security, our driving license, and our bank accounts. Okay, so our social security from our social security office is a unique table, right? For example, give you a scenario right now that you know. So now remember that when you need to apply to a driver license, you basically would go to the DMV with your social security, with your ID, anything to identify you, right? So they take those details, they enter it into their own database as well while creating those forms. So that way, your social security, which is a primary key, is now tied into the DMV table as a foreign key. It means that through your driver license, your social security number can be displayed, can be found. Also, remember, when you go to your bank, you go to your bank with your DMV, they ask you for, hey, where's your driver license? And show me your ATM card. They take your driver license and then they can set up an account for you. And when they set up an account for you, the moment they enter your driver license and all that, they can pull other details, your social security, and any other details that can be found. So you can see how data is surrounded, how data is surrounding us, and how these data they relate with each other. Your social security at the social administration office is a primary key. They do not need your driving license at the social security office, do they? They don't. They only need your birth certificate to issue you a social security number. Or they need your alien documentation to issue you a social security number. But you need that social security number to get a driving license. And on the job as well, you need your social security number and your work authorization to get a job. So now tell me, when the police they pull you over, how do they get the data? I won't say that. Using the police is far off. When you beat the red light and your tags get snapped, how do they know the address to send the ticket to? So you understand how data is related. That is where this your driver license is tied to a unique plate number, and that plate number is tied to your address, and that address is tied to you, and that you is tied to a social security number. You can see the relationship. Okay, so that basically explains the consistency we have with our data. We call that referential integrity. Data is clean and has to be, when the data is cleaned up, you should be able to find some level of integrity within your data. All right, so let's take a look at the demonstration that we have on here, just to get a clear idea. Okay, so we have a student with a primary key, with a last name, first name, date of birth, and they also have a group number, which we call a foreign key. And that group is a table on its own. Can you notice that we have a foreign key 123, and 123 here is tied to who? It's tied to both 8811 and 88112. And it's tied to the Faculty of Economics. 199 is tied to 88817. You can see 199 here, and you can see 119 here. It's a foreign key. So basically, we can basically take this table, do a join with this table, and then we begin to see this guy belongs to the Faculty of Economics. These two guys, Jackson and Peterson, they belong to the Faculty of Economics, while Depp belongs to Faculty of Mathematics. Using this group number. It's a foreign key. It's a foreign key. All right. So good. Good stuff. So I've explained referential integrity, but we can just take a look at this text. Referential integrity occurs when we have two connected relationships. Yes. The relationship of the relations is provided using a foreign key. A foreign key is an attribute of a relation, either subordinate or dependent, or points to a primary key of another relation, meaning it points to another key of another table. Referential integrity means that there cannot be a foreign key in the main table that points to a non-existent tuple in the subordinate table. Yes. You can see that those two tables are broken down apart. You can see the only thing that represents them is just this number. If you take out this number, these details gets duplicated here. So you're going to have economics, mathematics due to the fact that we can join with this number. Okay. So let's take a look at it. Well, let's see what the example says. There are two relations here, student and group. The group has an attribute number, which is the primary key, and the student relation has the same attribute, which indicates that the student belongs to a certain group. In student relation, the group number is a foreign key, and if in the student table for some tuple and the value of the foreign key points to the tuple of the group that is not in the group table, then there will be a violation of the referential integrity. So if these values here, if this is 120 and this is 123, there is no way you can connect these two dots together. Does that make sense? Those are the instances. This is a rule here. This group number is a primary key on this table, but is a foreign key on another table. By joining these two together, you can get the details, what ties Jackson to Peterson and Depp. So take a look at this referential integrity from that snapshot that we had earlier. You can see that we can use this foreign key to create a many-to-one relationship or a one-to-many relationship. All right. So now take a look at this. You can see that this 1 to 3 is tied to these two students, which is more like a one-to-many. See, just 1 to 3 ties to both students. They share the same faculty. All right. Then if you take a look at 199, it basically ties to one-on-one, one-to-one. But it can also be a one-to-many, and it can also be a many-to-one. Because not one student, more than one student can take the economics, can be in the economics department and can also take the economics course, right? The same way. So it's either a one-to-many or many-to-one. One student can take the course, many students can take the course. Similar to what's happening right now. Many students can take the SQL training. One student at a time can also take the SQL training. So there is a relationship that you need to understand in real life. Similar to when I talked about the library, how you borrow a book, another person borrows the book. There is an ID to that book. That is how they track, hey, you have not returned that book. There's an ID to it, and there is an ID and there is a date to it when it was borrowed and when it's to be returned. Okay. So those are key things that we know about this data. And when you begin to play around with your data as well, you would understand the different part of the caveats, the warnings that we get with data, just to make sure that the data is conforming to the rules that has been set, which we call the business rules. Okay, so let's take a look at this text as well. There are relationships in relational data model, right? We talked about one-to-one. One record in the table A. Let me give you a scenario, okay? One-to-one relationship. one record in table A relates to one record in table B. Example. One person and their passport, your international passport. The question I have for you, can your brother use your international passport? Can your dad use your international passport? That is a typical example of one-to-one. Similar to your driving license, it's a one-to-one. Only you is tied to a unique driving license. So that's what we call a one-to-one relationship. Let me go back to one-to-many. One record in table A represents or relates to multiple records in table B. One record in table A relates to multiple records in table B. Example, a group and a student. Okay, say for example, when I do breakout rooms, you notice that you have one breakout room, 7 people. Does that make sense? One breakout room, 7 people, like a group and a student. A group, breakout rooms, 7 breakout rooms, but each of those 7 breakout rooms has got 777 or 888, depending on the number of people at a time. So we can consider the one-to-many from the previous example, a group and a student. Okay, let's jump back. Take a step back to that table real quick. You can see here 1, 2, 3, 1, 2, 3. All right, 1, 2, 3, and then you can see this 1, 2, 3 here, which is a group and the student. See 1, 2, 3, just one key here, which is a primary key, but is connected to 2 students here. A group. This is a group, but 2 students. Okay, one too many. Okay, so let's go back. Also take note of a relationship I talked about, which is called many to many. Okay, I'm explaining in such a way that you won't forget. Many to many. For instance, again, records in table A relate to multiple records in table B and vice versa. Records in table A relate to multiple records in table B. An example, students and courses. Okay, students and courses, right? You know, there are in a typical college, there are lots of courses, right, in your department. So for those courses, there are a lot of courses, and students do sign up to those courses. Students sign up to those courses. You can have economics 201, economics 203, economics 205, and you have 200 students sign up for 201, 200 students sign up for 205, and a mix like that. The courses, they all have IDs, and they have many students signing up to them. Okay, let's take a look at the text after explaining. One-to-one relationship means that one tuple of the first relation can be associated with no more than one tuple of another relation, which is what I'm saying is one record in table A relates to one record in table B. One-to-many means that a tuple of the first relation can be associated with one or more tuples of the second relation, meaning one record in table A relates to multiple records in table B. Example was the group and a student. So we also talked about many to many, right? Many to many relationships, has to do with a tuple of the first relation can be associated with one or more tuples of another relation. The opposite is also true. For example, student discipline. Each student studies many disciplines, and each discipline can be studied by many students. Yes or no? Yes. Yes. For example, this SQL training back in the day used to be tied to computer science, right? But now anybody from any part of the world, any workspace can study SQL, can study computer science. That is many to many. It has no bounds. Records in table A relate to multiple records in table B, and you can switch it around the way you want. All right. So let's jump to the other slide. I will talk about relationships. Oh, yes, we talked about relationships where described identifying or non-identifying. A relationship is identifying if the foreign key of the subordinate relationship goes into another or become part of the foreign key of the primary key. Say, for example, the order number in the store is generated based on the customer number and the order date. The customer number is the primary key for the customer relation. The order number is a composite primary key of the two attributes. Let me explain that. It's just this is just checking relationships, right? So as a customer, when you go to the store, right, there is when you make a purchase, there is a customer number that is generated. And while that customer number is generated and you make an order and your order is finalized, you made the payment and order, an order number is generated. And again, while that order number is generated, while the order number is generated, the date is also generated as well. And for that order number that is generated, there is an order table. The order table takes care of everything you ordered, right? And the customer number takes care of your details, your name, your demographical data, your card ID, all those payment details and all that is covered in the customer table. So when we need to make a reference, the order number is a primary key on the order table, while your customer number, your details, when you register as a customer, the customer number is the primary key on there. And then we can generate the order number using the date you use in registering. Those are some attributes there. So in some instance where we don't have a non-identified relationship, the foreign key relationship does not go to the primary key. For example, the student group relationship discussed above is a non-identified relationship. But in a relationship that's been identified, is a typical one is transactional. A transactional relationship is identifying. We basically want to know if the foreign key is a subordinate relationship when it goes into the other primary key and it becomes a full part of the table. All right. So let's talk about the pros and cons. One of the main reasons why we do a relational data model, it's the fact that we use a powerful query language, which is SQL. And this SQL, basically, we know it's a structured query language. And this relational data model is basically based on mathematical principles. We call that mathematical principle set theory. Set theory. If you've done sets, where we talk about union, or talk about union, we talk about intersection. We talk about Venn diagrams. If you remember all those, those were they are part of set theory. That's the pros. We're using SQL to do a lot of stuff. And one of the disadvantages, it requires a translation layer for the object-oriented programming. And a lot of people, they face scalability issues with very large data sets. When data set is too large, we'll probably have some issues with that as well. So while trying to explain this, one of the main reasons for why RDM is so popular is that The query language, SQL, you can easily interact with the table. Yes, we can say that. And of course, you see how you interact with your users table. It makes it easy to interact with. Another reason is that it's based on mathematical apparatus, which is a set theory. Yes. And for large data volumes, the database management systems implementations based on order, usually simpler but less general. Data models can be more scalable and performant than relational database management systems. Some have a lot of issues trying to process or ingest large data sets. That's another concept, where we begin to talk about big data. That's another different concept that, with big data comes in where we talk about the velocity of the data, the volume of the data, and the veracity of the data. That's a different subject and course entirely. So there's also the disadvantage, where for RODMs, we basically would need some object data model that requires some extra layer. While we try to add all those extra layer, it increases the code complexity. It now depends on what language do we need to use and all those kind of instances. There are a lot of pros and cons to it, but the pros is what's relevant to us. We're able to query the language or query the data with SQL. Let's jump to the next slide. All right, so we can basically conclude that a relational data model is fundamental to modern database design, and understanding entities, attributes, integrity constraints, and relationships is key. We need to understand our table, very, very important. We need to understand our columns. We need to know how to pull them, how to analyze our columns, how to make sure that our primary key is tied to a unique row. And once we have this knowledge, it will help us design, maintain, and query our databases and tables efficiently. All right. So basically, just like we have it here, the relational data model is rather complex and general concept that underlies most data management systems. Most database management systems undergoes this concept. How we create our table, how we make sure that we have these integrities. We want to make sure that we have this concept. So the information that you got from this topic reveals the magic power hidden from you under the hood of information systems. Basically, you've created your table and you know what the table looks like. Hopefully, this will help you design your database structure and make informed decisions on its modification. Because in the future, you will surely update and modify your table to do other stuff. So this is very important. Okay. And we can basically do some hands-on, do some classwork using our table. We just go and see how we can apply some relational data model concepts, to our table. And then we can also continue doing what we need to do as well. All right. So who's done using the describe keyword on their table? Describe your table. Describe users underscore your table. That meaning users underscore your name. Are we done?
Yes.
All right. So, a question for you. So, can you identify the primary key?
Yes.
Yes.
And what about the attribute? Can you identify the attribute? Attribute. Can you identify the attribute?
Yes, sir.
What are the attributes?
I think
Name.
field type, null, key, default, extra.
No,
No.
those are not the attributes.
Attributes are the column names.
Attributes are the column names.
User
User
ID,
ID.
User
first
ID.
name,
User ID, first name, last name.
All right.
Okay.
You want to ensure that you understand what each column represents. So you can see when you do the describe of your table, you're describing your table, and you can see the columns. The columns are the attributes, and the data type is integer, variable character 100 with a length 100, integer with a length 11, variable character with a length 50, date. And the null is, do we allow null for user ID? No. Do we allow null for first name? No. Do we allow null for last name? No. Do we allow null for email? No. Age? Yes. Some people don't want, they want to tell you how old they are. So, country? Yes. Sign up date? Yes. Meaning those could be, they could be null and they can be filled up later. All right.
Coach, please, I have a question.
All right.
Yeah, on the note, you said that the column are attribute and that the row are tuple.
Tuples. So
Tuple.
take a look at this. We are saying we are passing it. Describe users Romeo.
Mm-hmm.
So when you describe users Romeo, can you see what's happening here? These are the columns. This keyword is describe this table. Describe this table. Okay.
Okay.
You can say this is your table. It's describing it.
Oh, okay. Okay. Now I get you. Thank you.
So if you're looking at this one, you are representing it like a table, like, oh, this is a tuple. This is basically describing the characteristics, the metadata of this table. You can see they have the table here, right? User ID,
Yes.
just like the way we have it here. It's now displaying everything the way we want it. Does that make sense?
Yes. Thank
It's
you.
displaying the characteristics. That's what it describe. Okay, it's a keyword that you should know.
So,
all right.
please, based on the on what you are saying, so the user ID, first name, those are
Attributes.
attribute. So the field type, null, key, are they tuple? Tuple?
So now, if you're looking at a table, okay, now let's go back. Okay, let's take a step back so you understand what's going on. So
Okay.
if you're looking at this table, if you're using this a row, if let's assume that this is a table, right? This is
Yes.
the table we're looking for. Anything on this line is a tuple. Okay, but this is describing your table, what your table looks like. You can see it has a primary key, has all that. So if you're taking a look at these tables from here, select. This here, you can see user ID and all that. It's representing that this is a tuple. This is a tuple. The row is a tuple. Okay, the row is a tuple. These are the attributes. See the user ID, first name, last name that we saw from the description is right here. So a row is a tuple. A row describes the user. So this row is basically saying, hey, okay, the user ID of Alice is 908. Alice's email is aliceuc@example.com. Alice is 28 years old, and Alice resides in the USA. Alice basically registered on this app on the 26th of February, 2025. Does that make sense to you?
Oh,
That
yes,
is
it
what
makes
a
sense now.
tuple. A
Thank
tuple
you.
basically describes a record across. So you can see that this row description and this row description, they are not the same. 909 is for Bob or Smith. 908 is Alice. All right.
Okay.
All right. Thank you so much. So let's take a look at our tables. Okay.
So, coach, I've been raising my hand. I don't know why.
Okay.
Can I
Yes. Tell
talk?
me. Yes. I mean, I help you.
Okay, yes. So I want you to go back to the table. So what you're saying about the description of table that I understand because I want to be sure is that this is actually telling us like the way the table is being structured, like the headings, what we have under the headings, type of what's it called? The type of heading attributes that we have, like we have numbers that comes in figures, maybe like user ID, we have emails that comes in text and all that. But when you say null, that part that says null, no, what's that?
Okay.
And the
So
default.
the default here null means that we did not assign any value for default. So you notice that you assigned a current date when you were doing your insert. You did not
Okay.
you did not put any date there, right? Because on the create, notice, just
Okay.
take note, okay? Take note.
Okay.
In your create statement,
Okay.
you can see we had a default.
Mm-hmm.
The default is current date. Did you
Okay.
see any other default here?
No.
That is why you have null across that board. We've
Okay.
only assigned defaults to this sign off
Okay.
date as current date. Okay, that's why you have it here, current date.
Okay.
The rest is null. Okay,
Okay.
all right. All right. So let's take the other task real quick. Let's verify. I want you
sorry,
guys
coach.
to,
Excuse me, coach.
yeah.
Can you spell the tuple for us?
Tuple is Tuple. Tuple. Tuple.
Thank you.
You're welcome.
Hi, coach.
Yeah.
So can I say, simply put, the columns are attributes and the rows are tuples. Just
Yes.
okay.
That's a good comparison.
Okay. Thank you.
Yes. You're welcome. So we need to verify that all rows have a unique user ID. We need to verify that all rows have a user ID. Okay, we basically can do that. We want to verify that all the rows from users Romeo, has a unique user ID. So we would write that we call this entity integrity check. We normally do it a lot. You would do it on a day to day to make sure that you don't have duplicates in your table. And we've basically done it during our practice session as well. So doing this is more like how we utilize counts. And I'll try to write it just to save time because we are limited on time here. So to get this done, we basically would do select on the user ID. Okay, we'll select on the user ID, then we do a count. We'll do a count. We'll do a count star from users Romeo. Then we group by user ID. Okay, so first and first, then we would also let's complete it once and for all. So we'll say having we need to do alias on this as this, then having we'll take this or this, put this, we'll say greater than 1. Then we'll close it up. So basically what this is doing, this is basically running this to verify if we have duplicate user ID, which is entity integrity check, similar to what we say table integrity check. Entity same as table if you don't know. So when we run this, let's take this one out. You can call this like we're doing the table check. Okay, table check. So if we run this, we expect to see no data. So it means that that table doesn't have duplicates. All right. So without this, you would see what's going on. You will see what actually happened. So when you run this, you see every record is 1, 1, 1, 1, 1, 1, 1, 1, 1. So this query here is saying, give us records where this count is greater than 1. There is none. That's why I would say no data. Okay. All right. Thank you so much. So let's go to tax 3. So tax 3 basically, let's say, well, let's create something. We're going to do some imaginary stuff because we don't have other tables to play with. So referential integrity. All right, let's create a scenario. Just like the way we have it on that text. Let's assume you have another table called groups, okay, with group ID as primary key. Then your user's name underscore table has a column called group ID, which is basically referencing groups, group ID. Okay. So who can explain how you ensure that every group ID in the users table exists in groups? Who can explain that?
Can you say that again?
Let me try to break it down to what you can process. Okay, let's assume you have another table called DMV. Okay, another table called DMV. Okay, and your driving license, your user ID in your current table is the primary key to that table. Is the primary key to that table. Okay, and your user's name table also has that column DMV ID as a foreign key on your user's name table. Okay, your current user's name table. Okay, this is abstract. I want you to explain to me. So explain how you would ensure that every DMV ID in your users table exists in DMV. Except Omo. Who can explain that?
Is it by using the primary key?
Yes.
So you make sure that the secondary key is tied to the primary key. That way, if they run the secondary key, they can be able to find the primary key.
What's the concept of doing that?
So like I should give like a real life
Yeah, just think about.
example.
Just tell me. Like, what do you do to the two tables? What do you do to it?
You tie them together. Is
What kind
that
of
what
tie
you're
is that? Is that the keyword tie?
influential integrity?
What do you do to the
Referential integrity.
what tie? The keyword tie. What is tie?
Join. It's not join.
Join together.
Correct.
Okay.
You
Join.
join. You don't
Okay.
tie.
Is it the same thing as group?
Join.
As in
You
put
join.
them in group.
No, we don't group. Group is when you're trying to filter. You're trying to like aggregate, and then you filter them. Group. That's group. Okay. You join. Don't tie. All right. So using that scenario, okay, using that scenario, it basically see how you can just basically have like a journey map of how your users table and your DMV table is. So let's say, for example, let's try to write that query, an imaginary query, and then you see what's going on. So if we select, okay, let me go. Let me just do select here from users. That was Chini, right? Was that Chini or Ubani? Hello? Hello?
Chini.
Was
That
Chini?
was Chinny. That
That
was
was
Chinny.
Chini? Okay.
Yes,
So,
I'm sorry. I had to step out for a little bit. I have my headphones on so I can hear you, but I can't talk because I'm on mute.
all right.
But
Okay, so I'm just using users, your Chini, and say you. Okay. And say you. So to confirm the referential integrity of the two tables, we would now say left join DMV, your DMV table. You have DMV underscore Chini. Okay. Call that G, alias that G, and then we're going to left join on U dot user ID, and then G dot DMV user ID. All right. And then we're going to say where G dot DMV user ID is so we basically just wrote a query where it will find any user that does not match any record within your table. So It's either we write not null or it's null here. You see that we have this table, users Chini, and then we also have another table called DMV Chini. And we join them on the user ID. This being a primary key on users Chini, and this DMV user ID being a primary key on DMV Chini, and it's also a foreign key on user Chini. So we can now say return u dot star. So what u dot star does is it returns all the columns from user Chini. Okay. So it's similar to this funny query here. This is a funny query by Omo. Okay, so you will notice the table called staff Omo, and she's joining that with a kitchen order, and she's joining it on the kitchen order ID and then the staff Omo user ID. All right, so this is basically doing something different than this. All right, so this is also a table to test referential integrity between this user and the kitchen order table. Okay, so if you run this, you get to see what's going on there. Okay, so when you have this, basically, it's saying unknown column name. So you want to go take a look at staff Omo and then say what must have changed. That column name must have changed. Okay, so we go here and then take a look at the table. You can query the table as well, but I want to give you a visual representation of what's happening. So this is staff Omo, and her first name has been changed to F name. Okay, so if you come here, you just switch this out. You see here, I'm following this arrow, I'm tracking this arrow to this table. And I'll clear this to see if there's anything new. And this is what's going on. You can see that the join basically brought more records. The first name, last name, email, may know what the person bought. The person bought some spring rolls. Let me see a word name there. Okay. Oh my goodness. All right. See what the person bought, how much the person paid, how much the balance is, and all those kind of stuff. So, and again, if you take a look at this table on its own, if you take a look at the table, the staff Omo table on its own, you see the table doesn't have all those other details. The table just had Patrick, Hanley, and the name. You see, she was able to do a referential integrity by joining these two tables to kitchen order. All right. All right. Yes. Any questions so far? Any questions? All right. So now let's do some crazy fun.
No question, but do you mind just breaking that query again for us? Thank you.
Which of the query?
Yeah, the staff Omo.
The staff Omo is a joint query, which is a different topic. I don't want to confuse you, but I just like you to know what happened to the concept.
Okay.
Or if it takes breaking it down, of course. So basically, what happened here is we're doing an alias. So it would more like saying, okay, this table name here, staff Omo, should be represented as, it's also known as staff Omo. That is why you have staff Omo.f name, staff Omo.last name, because anything with the alias staff Omo is coming from this staff Omo table. So for the same way it goes to kitchen order. When you take kitchen order, Same way goes to kitchen order as well. It's an alias. So when you say kitchen order dot kitchen order, you can see you can have this as A, you can have this as anything you want, but let me make it a bit simple. Let me break it down somehow. Okay. Let me break it down somehow. I'll make stuff almost A. All right. So then I make kitchen order B. So it doesn't look confusing. So if you've been coming to the practice class, you would have seen we talked about alias. So I won't take the context of alias here. We'll take the context of alias in the practice. So would navigate to kitchen order and make the change. So this becomes B, this becomes B, this becomes B, this becomes B, this becomes B. We skip that because that's the table name. We do this on this, we do this on this. So yeah, I basically broken down the query to what you can see. You can see we alias this as A. So all the columns coming from staff Omo A is coming. You see staff Omo here, right? You can see Omo has F name, last name, email, age, country, and all that. It's coming from A. Anything that has A is coming from staff Omo. Anything that has B is coming from kitchen order. So to join both of them together, you can do A user ID and B ID as well. So if I do not want to use staff Omo, if I switch this table around and use somebody else's table, let me say I take this person's table, users, let me say users Diane, and I run. What happened? Diane has not made any change to her F name. Diane's table still has first name as a column. Okay, so it means that I need to replace this again as first name. So hopefully she has records on her table. Diane doesn't have data on her table. So let's look for someone who has, let's see, users princess. Yeah. Users princess. So print. So if we run this, users princess has not made any updates to her first name. So you can see the relationship there. It's just a join, right? So you can Alice Johnson, Bob Smith, and all that. This person has not been practicing. If you've been practicing, your table will not be first name. Your table at this time should be F underscore name. All right. Those are some few tricks we run to make sure that you're practicing. So that is just a breakdown of that table, simplified version. So you see what's actually happening. It's nothing complex. It's just as simple as ABC. All right. So we've basically written a join query that combines the user's name and then a typical kitchen order. We're just basically checking the relationship between these queries. So another thing you want to do, probably you want to take your friend's table or your colleague's table, do a join, and then see if your table and that table they have common relationships in terms of user ID as well. So basically, this basically leads us to a point whereby we talk about how the join reinforces a relational model. using the join helps us to know if there is a relationship between two tables. Sometimes when you join two tables, there is no records, similar to how we tried joining users Diane and the kitchen order. There was no data because there was no relationship between the two. There's no common rows, no common columns, and all those kind of instances. And yes, any question? Any question? All right. If no other question, let's jump back to the
Yes,
slide.
I have a question, Coach. Can
All
you run
right.
the code you wrote earlier on top of the previous one?
Which one are you talking about?
Notes.
The select u dot star from user Chini.
There's an error there.
Oh, the
This one right
differential.
here.
This?
Yes, sir.
You want me to run this one?
Yes, sir.
The table doesn't exist. This is an illustration, right? This was an illustration.
Okay, got you.
DMV
All right.
Cheney doesn't exist. This was an illustration. You can see
All right,
there is no difference from what we did here and what we did here. So this table
exactly.
does exist. This table, the reason why this, okay, now I'll run it so you see what I'm talking about, okay? This table was an illustration telling you users Cheney has details in the DMV, right? So if you run this table, you would see, let me open up the errors. So now for you, what do you think the error will be?
The table does not exist.
Okay, let's see what's going to happen. So you can see what's happening here. Users Cheney doesn't exist. That's one. But users Cheney probably should exist. Maybe it's a capital C. It's an illustration, okay? I expect the DMV Cheney to fail. And so if
Yeah,
we run
capital letters.
this, we'll have DMV Cheney does not exist. Okay, no such table. So it's an illustration, okay? So to get the perfect illustration here, the illustration is just doing the join and then tell you what we basically should do.
Coach,
Creating the
if you
table is not
run,
rocket science. You can do that as well. Then this basically runs that inference. Yeah. It's not different. So it's just like me I can decide to take users Cheney table here and relate it with a table created by Omo. Omo created this table, So, and if you run this, if there is a relationship, okay, yes. So what this infer is first name, Chini has been practicing. So Chini has updated her first name to F name, which is in the marathon. If you've been running the marathon, your table names will not be the same. So those are first instances you can tell. So for Chini's table with this kitchen order, you'll notice that there's a relationship between her table and the kitchen order. You can test your table as well if your table has a relationship with the kitchen order. And then you can have records. So that was what I was trying to explain and depict the relationship between two tables. Okay. All right. Any other question? Okay. So now for me to you is we need to take next steps of making sure you practice additional queries on your own, review the classwork, ensure you understand the concepts, and then try to bring a lot of concepts together as well. And make sure you take the marathon SQL queries, run them as much as you can. Try to switch the columns and the attributes and the entities, just to make sure you understand what's going on. When you run that, make sure you put comment under your query. So in case you have any other question, you can get back to me or put a message in Telegram or any of the support colleagues. That there are a lot of colleagues that does support me here. So you can put a question to them. They'll be super happy to help you out as well. I want to say thank you and have a good night. If you have a question, just put it out there. I'll stop the recording at this point. Thank you so much and have a good night.
Coach, hold on.